Good afternoon, sir. This is Chandrasekhar, Senior Faculty of Physics. I have 15 years experience in teaching, particularly in medical field and IIT wing. Today we discuss about first year topic that is very important to enter the physics. That is actually in academic point of view, the chapter name is motion in the straight line. Motion in the straight line. Actually, this is the chapter name. So, according to this chapter, the weightage of the topic or chapter, particularly in MPC stream, nothing but first mains level. In mains level, in past years, one question was given, and advanced level, based on this concept, one question given. In need point of view, one question is also given. So in every competitive exam, they must give one question. So in future also, according to the topic, one question will be given. So according to the chapter name is motion in the straight line. So before going to the topic, we are divided the chapter name into words. Particularly, motion is the first word, in second word, the third word, and complete straight line is the fourth word. According to physics, there is no need to explain the prepositions according to English level. So there is no necessity for in and the meaning. So according to the chapter, what the words are required? One is motion, another one is straight line. So we must learn about motion and straight line. Before going to the topic, this chapter actually going to the topic, particularly kinematics. This is the actual topic, kinematics. So what is kinematics? So before going to the kinematics, first of all we can explain about mechanics. In every topic, last three letters can be taken as ICS. This ICS means physics. ICS means physics. So mechanics is the branch of physics. First of all, mechanics is the branch of physics. According to mechanics, we can explain the complete behavior of the body. Which body are you taking? That body complete behavior can be explained on the basis of mechanics. So mechanics is the branch of physics which can explain the complete behavior of the body. So that is the mechanics. So we can explain complete behavior. According to the scientist Newton, this mechanics is divided into three parts. The first part is statics. The second part is kinematics. And third one is dynamics. So every topic, statics, kinematics and dynamics, last three letters ICS. So these three topics are the branch of physics. Nothing but which is the branch of mechanics. Mechanics is the branch of physics. So statics, kinematics and dynamics are the branch of physics which can explain one by one. First of all, statics. Statics is the branch of mechanics which can explain the behavior of the body, which is at equilibrium position or condition. So according to statistics, we can explain the body. That body must and should be existed at equilibrium. What is that? Equilibrium. Each and everyone knows equilibrium is nothing but the resultant force acting on it is zero. The net force value is zero, then the body is said to be in equilibrium. So, suppose you can consider one wall, nothing but you can consider one wall or any blackboard. You can apply the force like this. I am applying the force. The body position does not change. So you can apply the force. That body does not change. Nothing but you are applying the force value is zero. Nothing but you can apply the force and both applied reaction force. The applied force and reaction force which are in opposite direction, the resultant force is zero. There is no change in position of the body. Then that body considered as equilibrium. That body behavior can be explained on the basis of statics. That is the statics. Second one, kinematics. What is kinematics? It is a branch of mechanics which can explain the behavior of the body. Behavior of the body which is in motion. Which is in motion without cause of its motion. Nothing but you can explain the behavior of the body. That body must and should be in motion. So one body is moving state. That moving state can be explained on the basis of mechanics. What you don't know, without cause of motion, that body is how much amount of force is required. That body is how much amount of force or how much amount of frictional force is acting. There is no need of force acting on the body. That body is in moving state, you can explain the behavior of the body. Then the physics or mechanics can be called as kinematics. And next one is dynamics, which is the branch of mechanics, which can explain the behavior of the body. Behavior of the body with cause of its motion. Here also, dynamics also explain the body, behavior of the body which is in motion, particularly which is in motion. But here they can require the how much amount of force is required to move. Nothing but suppose you can consider one body like this. This body mass is m. So you can apply, there is no external force, nothing but you can apply, there is no external force, nothing but 0 Newton. So you can does not apply the force. The body is said to be in rest. You can apply 10 Newton of force, the body which is in motion like this. Without cause of its motion, nothing but you are applying the 10 Newton force. There is no requirement of 10 Newton. You can apply the 10 Newton, the body which is in motion. Particularly from this point of view, from this point to, you can explain the behavior of the body. Then the mechanics is called as kinematics. Including, nothing but, including the 10 Newton is also taking, then the body behavior can be explained on the basis of dynamics. So, kinematics, you can explain the behavior of the body without cause of its motion. Dynamics is the branch of mechanics which can explain the behavior of the body which can cause with the cause of its motion. This is the actual parts of mechanics, basic parts, statics, kinematics and dynamics. According to the chapter motion in a straight line, this topic particularly goes to kinematics. So this chapter actual name is kinematics. According to the past 2 or 3 years back, the kinematics chapter is split into 2 parts. One is motion in the straight line and continuous part is motion in the plane. These 2 parts can be belongs to kinematics. So in academic point of view, this chapter is second chapter in academic textbook. So motion in the straight line is the branch of kinematics. So before going to the topic, here we would like to explain, one is motion, another one is straight line. So motion, first of all motion. Before going to the topic motion, you must know about rest. What is rest? Rest is nothing but, suppose you can consider one body. This body is placed on the surface like this on the ground. This body of mass is m. You are placing the body at the location A. With respect to the location or position, the time is running. So nothing but present time is like as 3 p.m. After 3:30 p.m. the body position does not change. With respect to time, the position of the bodies does not change. With respect to time and surrounding, the position of the bodies does not change. Then that body is said to be at rest. Nothing but according to rest, position of the body does not change. Does not change with respect to time and their surroundings. So the position of the bodies does not change. Then the body is said to be is at rest. Best example. Each and every student must know blackboard. So today the position of the blackboard is existed on this wall. According to tomorrow the position of the blackboard does not change. So position of the bodies does not change means the body is said to be at rest. Next word, motion. Each and everyone knows the rest. Other than rest is nothing but motion. Other than rest, nothing but. According to rest, the position of the body doesn't change with respect to time and surrounding. With respect to, in place of does change. Nothing but. The position of the body changes with respect to time and surroundings. Then the body is said to be in motion. Nothing but like this. First, the body is placed here. The mass of the body is at the location A. The time interval is present time. You can take it as 3 p.m. After 10 minutes, the position of the body, nothing but the body is moved to like this. After 10 minutes, nothing but 3:10 p.m. The position of the body changes from A to B. The mass of the body doesn't change, nothing but M. But their position is changes with respect to time and surrounding. Then the body is said to be in motion. Best example. Every student is in motion with respect to time and surrounding. So best you can take the example is planetary motion. According to the planetary motion, I am considering two planets. One is we are existing the planet is Earth. You can consider other planet is Moon. So present each and every member existed with respect to on the earth. So every member existed on the earth. So with respect to moon, one of the person is going to the moon. He is observed me. So with respect to the moon, the earth is always be rotating, self-rotation and rotating about the sun. So each and every second, the motion of the earth is always be in motion. With respect to the moon, the earth is in motion. So you are also in motion. Another person, nothing but, he is also existed on the earth. With respect to earth, first person and second person, both are existed on the earth. With respect to first person, the second person is on rest because you and me existed on the earth. So with respect to relative motion, the velocity is 0. So first person with respect to second person or second person with respect to first person, the both are in with respect to rest. So these are the best example to explain the rest and motion. So present we are discussing main two words. One is rest, another one is motion. After that you learn about next word is distance and displacement. Distance and displacement. According to the general language, both distance and displacement are both are equal. But in physics sense, distance is completely different to displacement. So present according to physics science, we are explain about distance and displacement. What is distance? Distance simply called as path length. Path length, nothing but. Suppose first we are starting at the point A. We are moving like this. There is no particular going to the point B. From initial point A, final point B, we are going the path, complete this irregular path length can be calculated. Thus, irregular path length simply called as distance, which is indicated by letter generally D. The unit of distance is in CGS system centimeter, in MKS system meter. The dimensional formula, particularly dimensional formula must be expressed in terms of square brackets. The basic terms mass, length and time. Mass is indicated by capital M, length is indicated by capital L, time is indicated by capital T. According to the path length, here only length is there, nothing but mass is not existent. M power 0, L power 1, T power 0. So, the dimensional formula for the distance can be written as M power 0, L power 1, T power 0. That is the basic representation of dimensional formula. This is the distance, nothing but path length. Any direction you can go. So, according to the distance, there existing only magnitude. But there is no direction. Particular direction is not there. So, there is no direction. One physical quantity having the only magnitude, there is no direction. Then physical quantity is a scalar quantity. So distance is a scalar quantity. They have only magnitude, there is no direction. So distance only a scalar quantity having the only magnitude, lack of direction. Next one, displacement. Displacement is nothing but shortest path length. Shortest path length is nothing but the body must and move in terms of straight line. Suppose first one person is starting at the point A. After certain time interval, he reaches at the point B. So the shortest line, nothing but A to B, initial to final point, the shortest path is nothing but straight line. So the person traveling from A to B, they have the direction and they have the magnitude. So both the direction and magnitude is there. Then the displacement is a vector quantity. The displacement is a vector quantity. Here unit, which is represented by letter capital S, and unit. Here also measure the length. Measure the length in CGS system is centimeter, in MK system is meter. And dimensional formula, here only length is existed, nothing but M power 0, L power 1, T power 0. Units are not changed, dimensional formula is not changed. But only change is here the path length. That path length must be in the straight path, that is called as displacement. Here there is no direction, here there existing direction. So it is a scalar quantity, it is a vector quantity. These are the basic terms. So according to these terms, you can go to the best examples. These examples are also given in the competitive exam. So first one. A particle starts at A. A particle starts at A. After certain interval of time, this particle moves on the curved path like this. After certain interval of time t, the particle reaches the point B. So, starting point A, ending point is B. According to the positions, the starting point with respect to x coordinate is x1 and x coordinate is x2 after certain. So from this point A to this point B, the required time is small t. During the certain time interval small t, the particle reaches the point B from A. What is the distance and displacement? So according to this application, they are asking distance. Distance is nothing but path length. There is no particular direction. So arc length AB. So you can calculate the arc length. This path length can be calculated. That goes to distance. What is displacement? Each and everyone knows Displacement is the shortest path. Shortest path is nothing but straight line. So you can draw one straight line from initial point to final point like this. So displacement is from A to B. It is a vector quantity. It is represented by AB bar. According to positions, the starting position is x1 and ending position is x2. This AB bar can be represented by final position minus initial position. It is a vector quantity, it is a scalar quantity. This is the first example. And second one, directions are given. So this is north, this is south, east and west. One person starting at the point A. Here one person is started. After certain interval of time, the person moves towards the east and reaches the point B. From A to B, the distance is 4 meter. From A to B, the distance is 4 meter. After reaching the point B, he changes his direction from east to north. He moves towards north and reaches the point C. From B to C, he covers 3 meters distance. What is the distance and displacement? In this second application, they are asking distance and displacement. According to the distance, first of all, I am calculating distance. What is distance? Only path length. The starting person is started at point A, reaches the point B. He covers the distance is 4 meter. So there is no direction required. 4 meter. After time, from B to C, he covers 3 meter. Nothing but plus 3 meter. So finally he covers 4 plus 3 is nothing but 7 meter. There is no direction is required. The total distance is 4 plus 3, nothing but 7 meter. What next? We are asking also, displacement is also asking. Displacement is nothing but the shortest path between initial and final point. The initial point is A. The final point is C. So the shortest path between initial to final nothing but like this. So according to the ABC, it is a right angle triangle. So according to right angle triangle, the displacement AC can be calculated as AC is equal to, by using Pythagoras theorem, square root of AB square plus BC square. Here AB value is 4, 4, 4, 16. BC value is 3, 3, 3 is 9. Root 25. Root 25 is nothing but 5 meter. So according to second application, distance is 7 meter, displacement is 5 meter. From this application, we conclude that distance always be greater than the displacement. Distance is always be greater than the displacement according to the second application. Third one. One person starting at the point A. He travels on the circumference of the circle, particularly half of the circumference. After the certain time, he reaches the point B. The circular radius can be taken as R. He going to the point A to B like this, nothing but in a clockwise direction. From this point of view, what is distance and displacement? So first of all, distance. Distance is nothing but path length. So starting point A, ending point B, he moves on the circumference. He covers half of the circumference. So distance is nothing but arc length. Arc length. So what is arc length? Here the arc length is AB. Nothing but AB is nothing but half of the circumference. So circumference of the circle is 2 pi r. So 2 pi r. Half of the circumference is nothing but by 2. Here 2 get cancelled. The distance value is pi r. Each and everyone knows pi value is 3.14 times of r. And after calculating displacement, displacement is nothing but the shortest path between initial and final point. initial point is a final point, nothing but shortest path is nothing but straight path, like this. So AB bar. So here considered as a center, AB bar can be taken as AO plus OB. AO value nothing but center to any point on the circumference is nothing but radius. So R plus R, nothing but 2R. According to this application also, distance value is 3.14 r, displacement value is 2r. So according to this application, distance value is always be greater than the displacement. So in the from second application, distance is always be greater than displacement. Third application, distance is always be greater than displacement. And next one, fourth application. One person starting at A and reaches the point B in a straight path like this. What is distance and displacement? This straight path, the total length is 5 meters. So according to this application, distance, the path length value nothing but 5 meter. Displacement is shortest path from initial point to final point, which is a straight line, nothing but which is also 5 meter. From this application, distance value must be equal to displacement. So according to the application 2, application 3 and application 4, finally we conclude that distance value always be either greater than or equal to displacement. We can go in a straight path, distance must be equal to displacement. We can go other than straight path, distance value always be greater than displacement. One more application, that is fifth one. So there existing one circular path like this. The circular path radius is R. One person starting at the point on the circumference at the point P. In a clockwise path direction, he reaches some other point Q. In the other point Q. From he starts P and travels some distance and reaches the point Q. What is his distance and displacement? So this is a circumference. So this can be taken as center O. From center to any point on the circumference is radius R. From point P to O, this is also R. So these 2 points making an angle theta. What is the distance and displacement? So distance is nothing but arc length PQ. Each and every person know angle definition. Angle is nothing but arc length by radius. According to the diagram, angle is theta, arc length nothing but PQ. So angle theta, arc length PQ, radius can be taken as R. So the distance PQ value is nothing but R into theta. The distance value is R into theta. What the next one you can calculate? Displacement. Displacement is nothing but the shortest path between P to Q, nothing but P to Q. We can draw one perpendicular from O like this. You can draw the perpendicular line. This angle is divided into 2 parts, nothing but this is theta by 2, this is also theta by 2. This can be taken as L. According to the diagram, displacement PQ can be written as Pn plus Nq. According to the perpendicular, Pn value must be equal to Nq. So I am writing Pn plus Pn, nothing but 2 times of Pn, otherwise 2 times of Nq. So you can calculate either Nq value or Pn value. So according to the triangle, particularly right angle triangle, we can consider the sine angle like this. The triangle is like this. Here N perpendicular, angle is theta by 2. Theta by 2 is existed at O and other point can be taken as Q. We know that. What do you want? NQ value is known. O to Q. O to Q value is nothing but radius. So we can consider sine angle. Sine theta by 2 is equal to NQ divided by R. Therefore, NQ value is equal to R into sine theta by 2. This value substituted in the equation. The final displacement PQ is equal to 2R sine theta by 2. 2R sine theta by 2. So 2R sine theta by 2. According to this application is also known distance values are according to the application major part. From this application we conclude that distance value always be greater than sometimes equal to displacement. So that is distance and displacement terms. After completion of basic terms rest, motion, distance and displacement, we go to the next topic is speed. Next topic is speed. What is speed? This speed nothing but the rate of change of distance. The rate of change of distance. Otherwise, the change in distance per unit time is called as the change in distance per unit time can be called as speed. So the rate of change of distance can be called as speed. So speed can be written like the formula speed is equal to distance by time. Distance by time interval. So units according to the formula units, particularly in CGS system. Distance unit is centimeter, time unit is second, centimeter per second. In MKS system, distance unit is meter, time unit is second. So the basic units are centimeter per second or meter per second. For numerical point of view, each time we can mention in MKS system. So dimensional formula. Dimensional formula, distance dimensional formula L divided by time dimensional formula T. So dimensional formula can be written as mass is not there, m power 0, length is there, L power 1, time is there, L power minus 1. So the speed dimensional formula is m power 0, L power 1, T power minus 1. This is the speed basic definition. So the basic definition of speed is the rate of change of distance is called as speed. Dimensional formula is m power 0, L power 1, T power minus 1. This is the speed. So according to the formula, speed is equal to distance by time. Here distance is a scalar quantity. So speed is also a scalar quantity. Speed is also a scalar quantity. This is the speed. After that, one more definition is required, that is called as average speed. Simply can be called as mean speed. Mean is nothing but total divided by number of times. Here also average speed V average is equal to, speed is nothing but distance by time. Average speed is nothing but total distance by total time. Total distance by total time. That is called as average speed. One more definition is required, that is called as instantaneous. Instantaneous speed. Each and everyone known in railway station or bus stand, instant coffee, brew, Nescafe, sum of. Instant coffee is nothing but at that time they required. So in a similar way, instantaneous speed, nothing but the speed at a particular time is called as instantaneous speed, which is represented by V instant is equal to ds by dt, nothing but d by dt of s. This is called as speed. So speed can be represented the rate of change of distance is called as speed. This is called as instantaneous speed. So we can be represented by ds by dt. The first derivative of distance can be called as speed. From this equation we can calculate the distance also. In denominator term dt is there, going to this side, ds value is equal to v into dt. Integrating on both sides, integration of ds is equal to integration of v into dt. Integration of small distance is converted into large distance. S is equal to integral of v into dt. You know the speed value. From the speed you can calculate the distance. You can integrate the speed, you get the distance value. Based on these basic definitions, in numerical point of view, applications are required. So we are going to the next topic, applications. First application. A person starting at the point A, after a certain interval of time, he reaches the point B. What is the distance? What is the distance? So according to the initial and final point of view, the total distance can be taken as S. Application number 1. According to the total distance, exactly half of the distance covered with the speed v1, remaining half covered with the speed v2. What is the average speed of the person? They are asking average speed of the person. So according to the application, half of the distance covered with the speed v1, remaining half covered with the speed v2. What is the average speed? The basic definition for average speed is total distance by total time. What is the total distance? Total distance I am taking S by total time. I am assuming this distance is covered with the time t. So average velocity is S by t. But according to the data, t is not given. Only given is v1 and v2 speeds are given. This v1 speed is nothing but half of the distance covered speed. v2 speed is nothing but remaining half of the distance speed. The basic formula of speed is speed v is equal to distance by time. So according to the basic form, v1 can be written as v1 is equal to, here the half of the distance, nothing but total distance is S, half of the distance is S by 2. Remaining half is nothing but also S by 2. So S by 2 divided by how much? It can be taken as T1. So T1. So V1 can be written as S by 2 T1. In a similar fashion, V2 can be written as S by 2 T2. So from this equation, here distance by time is there. You don't know the total time. I am taking total distance by T1 plus T2. From this equation, T1 can be written as T1 is equal to S by 2V1 and T2 can be written as S by 2V2. This T1 and T2 substitute in this equation, we get S by 2V1 plus S by 2V2. In denominator term, you common S by 2. So numerator S divided by S by 2 into 1 by V1 plus 1 by V2. Numerator, denominator S can be cancelled. You get 1 by 2 into, you are taking LCM V1, V2. Here V1 is there, V2 time get cancelled, plus V2 is there, V1 can be cancelled. This denominator 2 V1 V2 goes to numerator term, that is 2 V1 V2 by V1 plus V2. This is called as average speed of the person. Nothing but this formula is used at what condition? Half of the distance covered with the speed V1, remaining half covered with the speed V2. So the average speed can be written as 2v1 v2 by v1 plus v2. So based on this equation, I am writing like this. This equation also writing 2 by v average is equal to 1 by v1 plus 1 by v2. This is also the same equation. Why you are using this equation? Here the total distance is converted into two parts, two equal parts. Some of time they are asking the initial point is A, the final point is B. This is divided into three parts. So the total distance, first 1/3 distance, next 1/3 distance, last 1/3 distance, covered with the speed v1, covered with the speed v2, covered with the speed v3. What is the average speed of the person? We are also asking average speed. According to this equation, how many parts are there? Three parts. So here, how many parts are converted? Two parts. 2 by v average. In a similar way, here 3 by v average is equal to 1 by v1 plus 1 by v2 plus 1 by v3. This formula is applicable for the total distance is divided into three equal parts. In a similar fashion, the total distance from A to B is divided into n equal parts like this. First part, second part, third part, and the last nth part. First part covered with the speed v1, next v2, v3, last vn. What is the average speed of the particle? In similar way, how many parts are there? N parts. So n by v average is equal to 1 by v1 plus 1 by v2 plus so on plus 1 by vn. This is the main application according to the equal distances covered in different velocities. Based on this application, in exam point of view, number of times are given one question, nothing but example. From starting point A to B, this total distance is covered into three equal parts. The first part covered with the speed 10 km per hour, second part 20 km per hour, last part 60 km per hour. What is the person average speed? They are asking. Number of times are given. So here three equal parts are existent. According to three equal parts, the average speed can be written as 3 by v average is equal to 1 by v1 plus 1 by v2 plus 1 by v3. So 3 by v average. v1 value is given by 10. 1 by 10 plus 1 by 20 plus 1 by 60. In both, LCM can be taken as 60. In 10, 60, 6 times, 20, 3 times, 60, 1 time. 6 plus 3, 9, 9 plus 1. 9 plus 1, 10. 10 by 60. 0, 0 get cancelled. This value is 1 by 6. This term, total term is equal to V average. On cross multiplication, V average is equal to 6 into 3, nothing but 18. Each and every speed in kilometer per hour. So 18 kilometer per hour. That is the final answer. Number of times are given this example. After completion of this second application. Application number. What is that application? So a person starts at the point A and covers the distance at point B. So the total distance is A to B. According to A to B, he covers some of the distance with the time interval t1, remaining distance with the time interval t2. With the time interval t2. This distance covered with the speed v1, remaining distance covered with the speed v2. Then average speed of the person is. According to average speed, basic formula is total distance by total time. Here total distance is given, is not given. So here A to B, I am assuming yes. Total distance is yes. Total time is given. Some time t1, remaining time is t2. T1, T2. Total distance is, I am assuming, sum of the distance, nothing but this is S1. Remaining distance can be taken as S2. So total distance can be written as S1 plus S2 divided by T1 plus T2. The basic definition of speed is equal to distance by time. Here the S1 and S2 are not given. You can calculate it. So distance is equal to speed into time. According to the first part, V1 speed, time interval T1. So S1 can be written as V1 T1 plus S2 can be written as V2 T2 divided by T1 plus T2. This is average speed. So, at what condition this application is applied? So, in the entire distance, sum of the distance covered with the speed V1 in the time T1, remaining distance covered with the speed V2 in time T2. Then average speed of the person can be written as V1 T1 plus V2 T2 by T1 plus T2. And application number 3. Application number 3. What is that? A person starting at point A, ending at point B. The total time required to cover this distance is exactly t seconds. So they are asking average speed of the particle. At what condition? The total time interval is t. Exactly half of the time interval covers with the speed v2. Remaining half interval with covers the speed v2. First half of the time covers with the speed v1. Remaining half of the time covers with the speed v2. Then the average speed is v average. According to previous application, here application is v1 t1 plus v2 t2 by t1 plus t2. Here t1 and t2 are not exactly off, but according to the application number 3, they are given time intervals is exactly half. Nothing but according to this application, t1 must be equal to t2 must be equal to t by 2. Substitute in this equation, we get v average is equal to v1 into t by 2 plus v2 into t by 2. T by 2 plus t by 2 is nothing but t. In both the equation, t by 2 can be common. In numerator, v1 plus v2 by t. Numerator, denominator t get cancelled. Then average speed of the particle is v1 plus v2 by 2. This formula is applicable at what condition? Half of the time interval covers with speed v1, remaining half of the time interval with cover speed v2. Then average speed of the particle is v1 plus v2 by 2. Based on this average speed of the particles in advanced level, in past years, in advanced level, one question is given. What is that? A person starting at the point A, he travels on the circumference of the circular path like this and reaches the point B. The radius of the circular path is exactly 2 meters. He started at the point A and reaches the point B during the time interval is 4 seconds. They are asking what is the average speed of the particle. This question is given in the advanced level, not in mains, not in NEET. So basic terms also given in advanced level. Some of the times are given. So average speed. So according to average speed question is, the basic definition is total distance by total time. So here according to the data, they are in clockwise motion is moving from point A to B. This is the circumference of the semicircle. So how much time required to reach the point B? The time is 4 seconds. So total time is given as t value is given by 4 seconds. So what you require? Total distance. The path is circumference, particularly half of the circumference. Half of the circumference, total distance. Half of the circumference value is pi r. Actually, total circumference is 2 pi r. Half is nothing but by 2. 2 to get cancelled. The half of the circumference is pi r. Pi value is known 3.14. R value is given according to the diagram is 2 meter. So 3.14 into 2, nothing but 6.28 meter. This is total distance. They are asking average speed. Total distance is 6.28. Total time is 4. 4 get cancelled. In 6, 1 time 22, 5 times 28, 7. So unit is meter per second. This is the answer. That is the answer. This question is given in advanced level. This question is given in the advanced level basic terms. So you must concentrate each and every point in this topic. Thank you, sir.